Guys, so today I'm of composite shapes. So it's when they're shape put together. We have to kind of break them apart, or you make them whole again and then subtract the part that's missing. So actually, let's go. So you will be given a formula sheet. For a while. Like, you won't have to worry about memorizing all the formulas. You just need to make sure that you understand what you need to do with those formulas. Just want to make sure. So, example for a rectangle. Area of rectangle, length times width. And it's going to be, you may see it one of two ways. The most common is 2L plus 2W, or 2 times the quantity of L plus W. So you're adding up the two sides first and then multiplying by 2. Both of these are the same. So this is before we would distribute the 2, and this is to happen, we would distribute the 2, which makes sense because you have 2 of the same lengths. And 2 of the same widths. So I would write these 2 down real quick. And I'm going to work on triangles next, and then also going to put up circle, and I will put up trapezoid. I don't make any today for trapezoid, so I figured we'll at least have those ready, because maybe I'll make one at the end. So try. It's 1/2 times height. So if I was to draw a little triangle, make it a right triangle. Turn this on too, so that it's nicer shape. Erase that and try it one more time. So you have your height, which is going to be perpendicular to base. Because I do that kind of tiny, so it's from base to top, the highest point of the triangle, and it needs to be perpendicular. And in case this was not super perpendicular, it's kind of. So you'll know it's the height because you'll see a little right angle. See something like this. Show you that it's a right angle. So this would be the height. Then you have your base on the bottom. It's the where the triangle sits. That's gonna be the base. And it makes sense that a triangle is gonna be half, kind of like our area for the formula for rectangle, because if you cut a rectangle in half, so if I was to cut this in half, like this way, it would be diagonally. So if I cut that in half, it would have a triangle. So that's where that comes into play. Now for a perimeter, for the perimeter of a triangle, I'm just going to add up all the sides. So when I say A plus B plus C, you can also remember this. It doesn't matter, but you're just going to add up all these sides. So I got A, you can still count B as your base. C, so all three sides you need to add up to get your perimeter. So then circle. Circle. Square. So you have the center of your circle. Have a line that either comes to the edge, or you may have one that cuts it completely in half. It goes through the center. It goes completely through. Diameter is gonna be, that's gonna be your diameter. So that's from edge to edge, and it goes through the center. So edge, center. Make sure it goes through the center, because if it doesn't, then it's not the diameter. And then you have the radius, which is half your diameter. So radius, if you double your radius, you'll get your diameter as well. That goes from center to edge. Radius, center to edge. Alright, and then for perimeter, we don't actually call it perimeter for a circle, we call it circumference. You'll see this big C. Oh, of course, now it turns into a circle. So you'll have two formulas for that. You can either use 2r, which might be easy for you, so you only have to know what the radius is. I times diameter, circumference, which makes sense because if I was to double the radius, I would get the diameter. So that's why that happens. Next one is for trapezoid. So that's 1/2 base 1 base 2 times height, and you may see where there are two bases are added together. You may see that on the opposite side of h. You may see it as 1/2 h times b1 plus b2. So for a trapezoid, your bases you can label them. I'm going to just make the top b1, bottom b2. Height is going to be perpendicular to the base, so you'll see the little right angle mark. So that would be, this would be our height right here. And then I'm going to label these differently because not always are you going to have an isosceles trapezoid. So you could have A and C because these lengths may be different. If it's an isosceles trapezoid, then those lengths will be the same. So A plus C plus B2, and you can rearrange this using the commutative property of addition. So we put the bases first, the A and C at the end. Put C first, it's whatever that you'd like to do. So make sure you have those written down real quick. Have written down. That. Okay, so this one. Sure, we're gonna get this first shape. So let's make this. So give you first dimension. Terrible. Start that. So I'm gonna do this a couple of different ways. The first way I'm gonna do method. So I'm sorry, back up a little bit. So I want you to find shape. So to find the area, it's back. Okay. Sorry about that, y'all. All right. So to find the area, we're gonna do to use the addition method, or we can use the subtraction method. In this case, we can use that. So I'm gonna give me 1 second. Should be. So to addition method, we're going to cut it. So cut it into two different shapes. But before, so let's find out what these missing dimensions are. So you'll have to use the other ones around it to find what they are. So right now we're missing this dimension and this one they didn't tell us right off the bat, but we can figure that out. So to figure that out, what we're going to do is we're going to take our longest side and take away the shortest side that's opposite of that we know. So if this is 10 and this is 4, if we were to go all the way up to 10 and then come back 4, how much would we have left? Well, we would have 6 units left. So this would be 6. And we're going to do the same thing for our width. So if we go up 7 and then come back 3, how much do we have left? We have 4. So now at this point, it's up to you to decide whether or not you want to, where you want to cut it, because there's 2 ways you can cut this if you're going to use the addition method. So what I'm going to do is, that's going to show up. It's black to cut it for right now. Okay. Actually, we have to cut it. Okay, so we have 4, 4. So we could see this as being a square. So we could cut here and then leave ourselves with a square and a rectangle. We could cut here and have 2 rectangles. So at this point, it's kind of what you want to do. I'm going to do square and the rectangle just to keep it a little bit different, but I can solve it both ways. In fact, that's what I'm going to do. So I'm going to cut it here first, and I'm going to solve that in red. So I have a square. It's an SQ, not a 5. That's an SQ. SQs for square, and then we have a rectangle, so I'm going to make that R. So let's find the area of the rectangle. So area of the rectangle of R. So to find the area of a rectangle, it's length times width, so LW. And the length of this rectangle is 10, because it goes the entire way for us, and the width is going to be 3. 10 is 3. So that gives us an area for the rectangle of 30. I'm using R for area just to remind myself that's for the rectangle. Square is a little bit different. You could still do length times width, but what's unique about a square is that both sides are the same length. So if you multiply a number by itself, you're just squaring it, so you can just then length squared or W squared. They usually do S squared, for the S stands for side length, so it's S squared. And for us, our side length is 4 squared, which leads us to be 16. And if you're not going to remember S squared, that's fine. It is on your formula sheet. But the other thing you could do is just do length times width. So 4 times 4 is just 16. Now that we have both areas, we can just add them together, because now we're just going to piece them together like Legos. So we have 30, so our total area, rectangle, is the square area, so 30 plus 16. If I add those together, I get 46 some units squared. So I'm just going to use, could be inches squared, centimeters squared, feet squared. I didn't give ourselves units right now, so just call it units squared. Now, let's say you didn't cut it there. You decided to make 2 rectangles. Well, I'm going to erase this. This time, black. So I'm going to solve this second way. So this is one way to do it. Here's another way to do it with the addition method. So cut it. So now that I've cut it, we got a rectangle. Alright, so we have two rectangles, so I'll write it over here. So I'm going to call this 2. So, and if I do rectangle 1, it's length times. So length can either use 4 or 7. The opposite's going to be true for the other one, so you'll times 7 or 7 times 4. Which is going to give us 28 squared. Rectangle 2. And be careful. A common mistake on a situation like this is to do 3 times 10. But this isn't the rectangle you're looking at. You're looking at this rectangle right here. So it's 3 times 6 or 6 times 3. Just gonna add this up. So 20 is 18. So 10 and 20 gives us 30. 8 and 8 is 16. So 30 plus 16 is still going to give us 46 units squared. It's kind of my notice. Same. So what I'm going to do now is I'm going to now with the subtraction method instead. So I'm going to have you copy that down real quick. I'm going to start to erase the red portion right now on the shape, just so that off to use. And you can pause this if too fast with erasing stuff. But just remember 46 for right now. That down here in the bottom left hand for us to check because it was the same for both. Just did that. So let's say we didn't want to do it that way. In this case, we could use the subtraction method. Now understand though that you will have to use the addition on some problems, and another one you have to just use subtraction. So that I'm just showing you both ways that you can solve this. You'll have to use both methods depending on the problem. In this case, we can use either one. Others, you can only use one of two. So this one, pretend like this whole shape back together. So it's really just colored so you can see together. Solid. back together, we would just have a rectangle, right? Like a candy bar with some square rectangle bite taken out of it. So I want to find out what is this area before the bite was taken out. So the original shape is a rectangle. So the original shape. So we're going to have width, and that length is going to be 10. It's the whole length, not just 4. 4 is only from here to here. I just drew it all together, so that's 10 times width, entire width of the original candy bar, 7, 70. That's our first rectangle. That's the big shape. Now we're going to take out this little shape. Take out what is missing. So now I have this out. So it's a 4 by 6, and that's still a rectangle too. Missing. Happens to be a rectangle as well, so I'll use an R for that. 2. It's gonna be like that length is going to be 6 times 4. So 6 times 4, 20. So instead of adding these two, because we have a piece missing right, since that piece is missing, that was voided space. You may also hear in art they call the white space negative space, because we have this negative space right here missing. It's no longer there. We want to know what this shaded region is. Find the area of that shaded region. We're going to take what shape used to be and then take away what is now missing. So we're going to do 70. So 70 minus 20, I'm just going to do the 20 for right now. It's going to be 50. And then 50 minus the extra 4 is going to be 6 squared. So we end up getting the exact same answer. So again, in this case, this problem, we could have done the addition method or the subtraction method, and you cut it into any number of shapes. I've also seen students where they cut it different spots, so you could have cut this into a little bit more complex shape where you could have cut here and then had a trapezoid and another trapezoid. That's another way you could have done that. You could have cut it into a bunch of different triangles. You could have cut this into a variety of ways, but it's best to make it as easy as possible for you. I'm going to erase this. This is 4 and 6. I'm going to put this back up in just a second. Because now we got and tomorrow subtraction because I made addition today. So with perimeter, this one's easier than another one that we're going to have later on, because all we have to do is just add up all the sides. We don't have to calculate circumference or anything. We don't have to calculate a missing side length because we've already done that. So I usually tell you to pick a corner. I'm this corner down here, and clockwise, and then start to add them all up. So 7 plus 10 plus 3 plus 6 plus 4, and it's best to go through like a little check mark to make sure that you got all the sides, because sometimes you may forget a side. So yep, so now I'm just going to add them up straight across. Calculate, so 7 plus 10 plus 3 plus 6 plus 4. So I get a since we're just adding up sides, we're not multiplying these. It's just be inches or centimeters. It wouldn't be centimeters squared. So perimeter is just not multiplying units and units, so you don't have to square these. So it's just going to be just whatever the units are. So and you know what? Out because so I'm sorry. So please ignore that. That should be 30. So I am going to do one more problem, and then I'm going to have one to do on our own. I'm going to do just this next one and the following one. Calculate the area as well, and their circumference. I'm sorry, and the perimeter. Dimensions in a second. So I'm going to erase this now. So this time I'm just going to do area on this one. I'm going to make some dimensions real quick. Let's make this one and 2. Alright, so I have seen this a couple of different ways as well. Probably this thing to do in my mind to cut here, since it's already cut for us, and have rectangle, triangle. I've seen up separate the triangle, so they do 2 triangle, rectangle. Could make this an entire big rectangle and then subtract the little out. That just seems like a so I'm just going to do this where it's just the one rectangle triangle. Okay. If you have a different way, please let me know. You can chat. So, or leave a comment too if you happen to be watching this later. So two shapes that we have: a rectangle, uh, rectangle is length width. So in this case, it's going to be 8 times 4. Oh, you know what? The other thing you could is to make this an entire rectangle again, and then subtract out the triangles as well. You could do that, or half the rectangle, since technically this way as well. But that's just another one. Anyway, 4. You can do this by 8 times 4. So 8 times 4, 2. So that's this dimension right here. I kind of just cut it. Now, for the next shape, triangle. This one's gonna be a little bit tricky because remember, triangle is half base times height. Our base though is from this corner to this corner. It's this entire length. Because if I was to rotate this, let me do. I don't think it's. If I was to turn this, base would be right here. We could set the triangle down just like that. So I have to know what this entire length is. So it's this 1 plus this length, which if this is 4, this is 4, so that's 1, 4, other 1. So 1 plus 4 plus 1, so that's 2 plus 4, which gives us a base of 6, times the height of 2. So two things. You can do 6 times 2, which gives us 12, and then divide by 2 or times 0.5, which gives us 6 again. Take half of 6, which is 3. 3 times 2, so there's a couple different ways, since they're all, it's just multiplication. We can use the property to move it around. But if we put this into Desmos, so right here, usually a mistake happens where they don't realize that the cursor is right next to the 2 in the denominator. Done with your fraction, press the right arrow or click to the right. I'll bring it back up next to the fraction bar. Keep going, so you can do times 6 times 2 and 6. So the total, we're just going to piece them back together like Legos. So 32 plus 6, 8, and all units again. I'm sorry, so that's units squared. So that'd be our final answer. Now, if we wanted to could do this, it'd be a little bit more work. I don't know if they'd ask you for something like this, but they may. So with this, since this is cut in half, this would be center to here 2, and 1, so this would be a 3 by 2 triangle, and use the Pythagorean, find this distance, and since it's an isosceles, same. I'm not going to do that for today. I can do that for tomorrow because I'm already a little bit over. But if you'd like to see that, if you could just let me know. Because that is a really good question to work through because it is pretty challenging. So I'm going to leave that one up just in case y'all tomorrow. So for this one, I'm going to help you set it up. So I'm going to cut this first. Well, first I need to give dimensions. So let's make this 5. Let's make this. Let me show you where this is at. So you got a semicircle, and this is going to be 5 by 7. So you have 2 shapes. So I'm going to find area and so the 2 shapes that you have is rectangle. So remember for the perimeter, I'm sorry, for the area, it's going length times width, and then circle is a semicircle. So normally the area for a circle is pi r squared, but since it's a semicircle or a half circle, to then divide by 2 at the end. So now the question comes into play, how do I find my radius? Well, if this entire length is 5 and it cuts from edge to edge and it goes through the center, do you think we could find the radius? Can. Radius is not going to be the full 5, it's going to be, remember, radius is half diameter, it's going to be 2 5. Okay, so I gave that hint for y'all to help you out. So that's going to be help you with the radius. So I want you to find, this is going to help you find the area, and remember at the end you're going to have to find the total once you find each one. And then for the perimeter, you still have the rectangle, but realize I would pick a corner and then add around the edges. So if this is 5, this is 7, you'll have to know what the side is. And then the trick to this one though is this semicircle again. So to help you with that, not only are you going to add up all the sides, you got to find the circumference first. And to find the circumference, it's pi, either pi, 2 pi r or pi times diameter, which we know. And again though, it's not a full circle, so we need to find half of it. So we're going to divide by 2. So I want you to try that one out. And then we'll go over that one tomorrow along with the perimeter of that last one. We'll end with that. We'll start with this, and then we'll end with the other one because that's a little bit challenging. If there's anything else you'd like me to go over, please let me know. And then I am still in the works of trying to get some new material out and trying to get all that set up for y'all, but I will let you more about that later. Right? I hope you're doing well, and I will see y'all tomorrow. I'm going to start working on algebra, so you can stop the video here. See you tomorrow. y'all. So today for algebra, I'm gonna go over some systems stuff. So I was gonna go over system of equations first, and then see how far we make it today, and whatever we don't get over with today, I'll push it into tomorrow as well. And then just go from there. And like I said, I'm still trying to get some new stuff set up for y'all. I have the first unit ready, or the first like lesson ready. I just want to make a few more first. So I may start that next week, or I may wait until after your spring break is done. And maybe I'll still do it over spring break if y'all feel up to working over spring break. I'm okay with that as well. So systems of equations. We learned a couple of different ways to do it. The easiest way, and actually, before I get started with this, let me get the Desmos open. Graphing calculator. There are ways to solve systems of equations. I'm just gonna label systems in general, because you can also do this for systems of well, most of them, I guess, just to say for system. Well, we'll just call it systems of equations, right? Systems of. So the three ways that we can solve it is graphing, which is the first way that we. So that's either plug it in into your TI-83. Oh, you can't see it. So TI-83, you could graph it by hand on graph paper. You could also just use Desmos. The nice thing about Desmos is you don't have to turn it into slope-intercept form. You could just leave it in standard form or point slope, and then just plug it in. If you're using your TI-83 or plotting by hand, though, you need to have it in slope-intercept form, and I'm going to put that in parentheses. So again, that's only if you're not using Desmos, it needs to be in slope-intercept form. So that's for So that's for this. Then the next way was substitution. So with substitution, you're going to solve for one of the variables. It doesn't matter which one. It could be x, it could be y, it could be using the first equation, it could be using the second equation. It's completely up to you. Again, you want to make your job or life as easy as possible when you're trying to solve for this. So pick the easiest one to solve for and use the easiest equation to solve for that variable. Sometimes either one, it's kind of a toss-up. So it just varies. Sometimes there's already one solved for you. But after you've solved for that variable, you're going to plug it into the other one. So in this case, there doesn't need to be any particular form. You just have to solve for one of the variables, so that you're going to use the literal equations, the methods that we use for literal equations during substitution. And for the third one, so for function, it needs to be in standard in order to solve for it, and you're either going to add or subtract. It kind of depends on what if you need to change the sign or not. If you need to subtract, you have to change the signs are the same, but the coefficients are the same. If you add, coefficients are the same and they're opposite signs, so you're good. For these problems, I have about 5 lined up. I am going to solve them in each method. So, if you're following along, please get some paper. I would recommend doing that. Again, it is, you pick what is ever easiest for you. The nice thing about Desmos is that you're going to be using it pretty much for the rest of your high school career, so you don't have to worry about anything. They also have the TI-83. You can do almost everything with Desmos with the exception of one thing, which is line of best fit. Get to that later. So that is something nice to at least use to check up on your work, but it is nice to also know how to do substitution and elimination, because it's still a lot of the algebra fundamentals, which is pretty key for Algebra 2, and if you decide to go on to later maths as well. Okay, so for the first one, and what I'm going to do is I'm going to erase this, and right here. There's one other thing I just really discuss before I started this, so I'm going to write these problems down and then discuss that. The other thing I forgot to go about is the of intersections with a system of equation. So when it comes to solutions, I'll just write this up here. Number of solutions. So for one solution, the lines will intersect. So there will be just one intersection, so the lines will cross, so lines cross at one point. If you have no solution, that occurs when the lines are parallel, so that occurs. So this means parallel, the two parallel lines that are vertical, that means parallel, so that's parallel lines. Means they have the same slope, so they'll never cross. And then you can have infinitely many solutions for all real number solutions, and that occurs when they're coinciding. Spelled that to C instead of S, as I want to know. It is with a C, so I apologize. I'm going to erase that and fix that with you. Coinciding lines. So what does that mean? That's when the lines are right on top of each other, or they're the exact same line. Okay, so they're the same line when it's dealing with coinciding lines. Down here, so just write those down. Haven't, if you need a refresher, you can write those down. And then I'm going to start working through the problem. I'm going to graph it by hand first, then check it with Desmos, then I'm going to solve it with substitution, and then finally with elimination. So I'm going to graph this line in red, and it kind of helps to color code it too, so you know, especially if you're graphing it and you're not sure which line is which, to kind of, and this one's going to, so let's graph the red one first. So this is already in slope-intercept form, so y equals mx plus b, where b is our y-intercept, so I'm going to put that at 3, 1, 2, 3. That has a slope of 4, so I need to go up 1, 2, 3, and over. And I can also go in the reverse order and go down 1, 2, 3, and over. 2. You don't have to put as many dots. I am doing this because I need to try to graph this as best as possible, because doing this on a little sketch pad is not the easiest thing to do, I'll tell you that. So to mess this up. So there's one. Didn't come out too bad. So now I'm going to do negative x minus 2. So I need to graph the y-intercept, which is negative 2, so down here. And then this is going to be a negative slope, so it's going to be down 1 over. And it continues. This point. It's really quick. For the opposite, so we already know where we're crossing. It's going to be so again, try to connect this as best as possible. This direction is much more. So try. Turn sideways to try to make this better, and it's actually making it worse. So if you see that scribble at the beginning, that's because I was trying to figure out which way is up, down, and I did it. Sorry. It's lightning. Okay, so chew. Alright, so it crossed only at one spot, and it crossed at -1, -1, because that's where we can see right here. So our solution is going to be -1, 1. This would be our answer. And then I'm actually write that substitution. So I'll write it over here just to make sure it's the answer. Actually, so let's check with Desmos if we got the same answer. It's from myself. Alright. Equals for x plus 3 x plus 2. And if I hover over where they intersect, which is going to be right here, -1, is that right? Yes, so we get the same answer. Just a kind of refresher over on Desmos as well. The nice thing about Desmos is it also gives you your intersection points, so where they cross the x and the y-axis, so your x-intercept and your y-intercept. And if you need to know it for your red line, you can just click the red line and it shows you here and here. And then that's your intersection points right here. And just to double check, I said you could also plot it, so don't forget your parentheses. Boom. So there's your point. It matches up, so you're good to go. And I am going to clear that because we're going to use that later. All right, so substitution, I'm going to do that in orange. This one's going to be really different, I'm going to say, just because we normally have one in if you want to use substitution, one's in standard and one's not. This happens to be both in slope intercept, so so they're actually technically already solved for a variable. In this case, it's solved for y for both of them. It's up to you to decide which one to plug in where, but it actually is going to look like the exact same problem. There was one IXL that I gave y'all that the word problems were like this, where they actually ended up being just set equal to each other because they gave you them both in slope intercept form. So what's going to happen is that I'm going to take wherever I see y, I'm going to plug this in. Now let's say you wanted to use this y instead to plug in for here. That's fine too. So, but it's again, it's going to look like the exact same. So wherever I see y, I'm going to plug this in. So this is, here's a y right here. So I'm going to plug this bad boy in here. So I'm going to have 4x plus 3 equals negative x plus 2. Okay, so this is what you would look. This is what it would look like. Granted, yours is probably not color coded, and that's fine. I'm just showing you what that would look. Where is it going? So at this point, excuse me. You're gonna want to just solve for x, just like a normal equation. And oh, it's back. Okay. So negative x plus x. I took away this x. If you wanted to take away 4x, that's fine. I just got rid of this one since it's already negative and we're just making it positive. So just to kind of, so these cancel, that's 0. So I'm gonna go back to just black. So 4x plus x is gonna be 5x plus 3 equals negative 2. So now we're going to subtract 3 from both sides. Positive 3 minus 3 cancels. So you got 5x. Negative 2 minus 3 gives us negative 5. And then we're going to divide 5 from both sides. Cancels. That becomes 1. And negative 5 divided by 5 is going to be negative. So there's the first part. We're not done yet, though. That only gave us our first coordinate, or gave us our x coordinate to be more specific. So because I don't need to look at this graph right now, I'm going to move over to solve for y. My goodness. Sorry, y'all. The internet today for some reason, so it's should be back. I'm sorry. I don't know what's going on right now. It dropped for a second. So again, I'm sorry about the pause. I'm trying to see if it's going to get back to live. We should be back live. Awesome. I'm really sorry. Can't see anything. I'm not sure. Normally I can hear what's now. It seems to be acting really funny. So hopefully you can hear me. Give me 1 second. I don't know if this is doing this. I'm gonna stop real quick and I'm gonna try it one more time because I should be hearing audio and I'm not hearing any audio. Seeing any response. So I'm gonna pause real quick. Okay. All right. Okay. So now we're back with, okay, so we got our x coordinates. Now I'm going to do my y coordinate. So I found out what this is. So now I'm going to plug this in for x into either one. It doesn't matter which one you pick. I think it'd probably be easier just to do the first one, but it's up to you, like I said. So if you want to plug it into the second one, that's fine. I'm going to plug it into the first one. So y equals 4x plus 3, and then I'm going to plug in -1 in for y. So 4 times -1 is going to be -4 plus 3, and then -4 plus 3 is going to be -1. So our final answer then would be -1, -1. And does that match up with our graphed solution? And it does equal the same one. So that's another way that you can do this. I'm going to erase this, and I'm now going to do it with substitution. I'm going to leave this up so we can still see the problem. So to do this with elimination, you need to remove one of the variables. So you're looking for ones that have the same coefficient and that are opposite of each other if possible. If they're not opposite, that's okay, because then we can just subtract them as long as the coefficients are equal. So in this case, we actually already have y, because the coefficient of y right here is 1, and the coefficient of y right here is 1. So instead of adding the two equations together, we're going to subtract, since the coefficients are not additive inverses. So it's 4x plus 3, y equals negative x minus 2, and I said we're going to subtract. So I'm going to put parentheses around the entire equation and put a minus outside. So y minus y leaves us with 0. 4x minus negative 1x is going to be adding, so that's going to be a 5x. 3 minus negative 2, so that's a double negative, so we're going to be adding 2. So 3 plus 2 is going to be 5. And then again, we're just going to solve for the only unknown that we have, which is x. So we're going to subtract 5 from both sides. I have negative 5 equals 5x. Divide by 5 on both sides, and you get negative 1 equals x. And we're off to a good start already because it matches up with our original x coordinate. So at this point, you can plug in this negative 1 into either equation. Since I did it for the first one the last time, I'm going to put it into the second one this time. The thing about this is if you had to multiply by a value to make the coefficients the same, you need to go back to the original equation. Granted, for this one, we didn't have to do that. I will have one like that. I think for the next one, don't have that option, so it will be on to a later one, but we will have that ability to show that, so just keep that in mind when we get there. So just make sure you always use your original equations that you were when you're substituting stuff back in. Alright, I think back again. I'm sorry, it keeps going back and forth. I don't know what's going on with this, but so the common mistake occurs right here with this negative. It's a negative x, so make sure you bring that negative down. Just because we have a negative 1 doesn't mean this goes away. It's still here. So negative 1 makes this a positive 1 because it's double negative, minus 2. 1 minus 2 is going to be negative 1. So our solution is negative 1, negative 1. And does it match up? Heck yeah, that does match up, so we are good to go. Alright, so I'm going to erase everything. Make sure you have that written down. If you're following along and want to write this down, pause it. If I'm erasing too quickly, I'm going to do the next problem. And then I will give you one to work on. Again, I'm going to go through all three methods on the next problem. I'm going to give you one to work through. And then we'll work on 3 then the next day. So, 2. All right. So the equation we're going to use is so 1, and then y equals negative 5 halves x plus 4. So that's a negative 5 halves, not a negative s2, or negative s over z. So it's a negative 5 halves x. Alright, so, graphing. Red, green, so y equals negative 1. Remember, if it's a y equals equation, so flux hoy, h horizontal, o was for 0 slope, and the y was a y equals equation, so it's just y equals an integer or y-axis, so we're going to cross just right through the y-axis at negative 1. So it's just going to be a line that looks like this. So there's our first equation, and then our second is going to be negative 5 halves x plus 4, so up 4, 1, 2, 4. So we're going to go down 5, 1, 2, 3, 4, 5, and over 2, 1, 2. And then I'm going to go down 5 more, 1, 2, 3, 5, 1, 2. 2, 3. We're not going to fit there, so we'll go up 1, 2, 5, 1, 2. So again, I'm going to try my best to make So where do they cross? They cross at 1, 2, negative 1. So 2, negative 1 is our solution. Alright, so I'm going to in just to see if Desmos comes out with the same answer that I just found. So and these are half marks, so I'm going to zoom out just a little bit just so it's a little bit easier to see. And then 5 divided by 2. Common mistake. Oh, common mistake is right here after they put in the 2. They don't click the right arrow on their on the control pad or D-pad or your right arrow, or if you click over to the right, just to get next to the fraction bar, because otherwise they'll put the x on the bottom and that makes it exponential. So we're going to put 5 halves x. It was plus 4. So we have our two lines. They cross at 2, negative 1. Does it match up? Yep. So our answer is good. Put that away. So that up, I'm going to move away from the graph, and I'm going to solve with substitution. This one's going to be a little bit easier to solve. because the y value is already found out to be -1. So look at that, that's a -1. Oh, that's fine. She can keep squeaking it. So you may hear some dogs playing in the background. So y is already -1. Let's solve this in orange. So I'm gonna plug this in for the y. So -1 equals -1. I'm gonna plug in right here for y. -5 halves x plus 4. I'm gonna subtract the 4. So let's do that in a different color so you can see it being eliminated. So -4. So cross this off. -1 minus 4 is going to be -5. So now I'm going to do the inverse. I know this is a little bit more difficult to see, so I'm actually going to rewrite this real quick. So this is -5 halves x equals -5. So you can see when I'm multiplying by the reciprocal. So there's two ways you can do this. You can multiply by 2, then divide by 5, or divide by 5 and multiply by 2 if you want to break this fraction up. But if you're multiplying by a fraction and you were to divide by a fraction, you're just multiplying by the reciprocal. So to multiply by the reciprocal, it's just going to be -2 over 5. And this is -5 over 1 because it's an integer. This cancels out, so this is gone, so you're left with x. Now, again, there's two different ways you can do this. Some of y'all are going to see, oh, this is a -5, this is a 5. -5 divided by 5 is -1. And it'd be -1 times -2, so that's just going to be 2. Or if you cannot see that, that is okay. You can just multiply like normal, so you multiply straight across. So you can just multiply straight across. So straight across would be -5 times -2, which is +10. 1 times 5 is just 5, and then 10 divided by 5 is just going to be 2. Okay, so that's another way you can do that. You still get the exact same answer. Hey, look at that. X equals 2, that's 2. Y equals -1, so our answer is still 2, -1. We didn't have to solve for y this time because it was already solved for us. I'm going to erase this. I'm going to tell you right off the bat that substitution and graphing is probably the easiest for this problem. I'm going to do elimination, but I think it's going to be just a little bit ridiculous for it, only because it's just, you only need to solve for one of them, because again, y is already solved for it. So I would recommend out of the two, if you had to do it algebraically, to do substitution over elimination, but that's just me. So I got y equals -1, y equals -5 halves x plus 4, and now I'm going to rewrite this one more time so everything's over each other. So this is y equals 0x. We don't have an x, so anything times 0 is just 0, so that's why I wrote it like this. -1 is -5 halves x plus 4, so now everything's over themselves. And this is what I'm going to cancel, because I can't multiply anything by 0 to give me -5 halves, so I'm not going to do that. And this time, since they're not the opposite sign, I'm going to subtract. So y minus y is going to be 0y. So that leaves me with just 0. -5 halves x, so 0 minus -5 halves x is going to be +5 halves x. And -1 minus 4 is going to be -5. So I'm going to add 5 to both sides. Cancels, so you're left with 5 equals 5 halves x. And again, I would just multiply by the reciprocal, so times 2/5. 2's cancel, because 2 divided by 2 is 1. 5 divided by 5 is 1. And I'm going to multiply that on the same side. 5 divided by 5 is just 1. So you're left with 2 over 1, so that's just 2 equals x. And again, that would be just 2 -1, because the -1 was already solved for us. I know it went pretty fast through that last method of solving it, so if you have questions, please let me know. I'm going to put another problem on the board for you to solve, and I just realized I forgot to finish up the other problem I gave y'all on Monday, so I will do both of those tomorrow, the one I gave on Monday and then the one I'm about to give tomorrow. So I'm going to erase this. So, problem I'd like you to work out, and it's just one, and I'd like you to solve it in each method, but if you just want to do either substitution or elimination, just at least pick one of those. I mean, because the graphing one's pretty quick, so at least do either a substitution or elimination for this next problem. So I'd like you to at least solve it in two of the three methods. So the equation is system of equations is gonna be y. Nope, it is not y. It's -7 x minus 2y is -13 x is 2y equals 11. So that's the system that I'd like you to solve. Again, I'd like you to at least pick a substitution or an elimination method along with graphing, because the graphing is going to be really quick with Desmos. And then we'll cover that tomorrow. Again, I miss you all a lot. Hope you're doing okay. And just let me know any questions that you have. You can email me, leave a comment. I don't know if I've seen any comments yet, so I don't know if I'm getting notifications for that. Or leave anything in Google Classroom as well. And I will get back to y'all tomorrow, and I'll let you know more about the new lessons once we get a little bit closer to that. Alright, bye all, have a good day. Joash, I'm not sure if you're still here, but for the schedule, usually it was gonna be, as of right now, it was supposed to be Monday, Wednesday, Friday this week, but Wednesday kind of snowballed into like I had a lot more I had to do. So I'm gonna schedule for tomorrow. Next week, I think I'm gonna do Monday, Tuesday, Wednesday, Thursday, but I'll put a post up in Google Classroom each time. So hopefully I can be more consistent. I'm still trying to figure out what's a good schedule for y'all, or if just putting the post in Google Classroom is good. For some reason, none of the questions were coming up. I don't know why I couldn't see the chat until after I almost left. So, yeah, let me know if there's days better than that. If you can fill out the thing in Google Classroom, that kind of helps me out too. Like what type of schedule you'd rather see. If the post Google Classroom is a good enough notice, whatever's good, right? But yeah, I will be on tomorrow, probably around the same time and probably the same length. I went a little bit over to, well, actually more over than I was planning, but that's fine because I would rather go through as many questions as possible to help y'all. But if there's anything else you want me to go over, I'm going to do systems of equations again tomorrow, and then inequalities later.